So you want to catch them all, but you want to be mindful of what you send over the wire, obviously. Well, that sounded cryptic. Let's go. We're going to build another Waku project, although it's not really anything specific to Waku. But do check out Waku. It's wonderful, really. It's really the minimal way to get React server components. And once you get the hang of it, I really can say that, yes, this really is the right direction moving forward. So yeah, if you haven't really touched on it, or you're just not considering React server components, because then you need like Node on the server instead of your other thing you're using. In any case, like, dig into this. This is good stuff. What I like to use in some like demo projects or test projects is the Poke API. It's like a RESTful Pokemon API. It has a lot of information and data you can require and fetch. But like any good REST API, it never has that one endpoint that gives you the thing that you're after. You always have to mix and match these things a little bit, which is perfect. And it's good to play with in different languages, different strategies, frameworks, all those things. So what we're basically working on is a little overview over here, where we get a batch of Pokemon, the monsters, and we're just gonna show them all. Now, the thing of note is there are over 200 of these buggers. So this is all working very fine. We'll get into the code a little bit later on, but you can see that we already have 200 and more requests, and a lot of them are just, images. Like, we have 200 of these monsters, so we need to give 200 images back. So if we take a look at the code, our server entry, that's like your entry point in Waku, where you can define what pages you have. So if you're brand new to Waku, it's just really, install Waku like this, set up your config, and I'm using Tailwind, I'm using ReScript. So we have our server entry. There we're creating 2 pages. We're not going to look at the index page for now. We're just going to have a dynamic page, and that's going to mount to a server component. We give this a path, and the reason this is dynamic is that we might end up, doing something more with our overview. For example, later on you can select which ones you caught in the game, and then we need to update the data. So the data right now is really just it's a file with JSON, and I sort of, fetched some of this from API call thing, the Poke API initially, because, it is rate limited. If you're constantly, requesting the same data all over again, it just makes sense to cache it. So this is really just a cache, and it's, aggregated data of what we actually need. So you can see that all these things have like a sprite, and that's what we're loading one by one. So in our server components, if we take a high level look, it's an async component, so that's wonderful. You can just do a get data, and you're allowed to do that on the server, and it just simplifies things. Because think about it, what if you send all this information to the client, React finally loads, the browser did all the things that came before that, and then the first thing your component does is fetching data. And I have to admit, that's just, very much my React experience, and that's where they're trying to, push people away from, doing fetch on render. So instead, there's nothing particular that has to happen on the client here. So just doing this on the server makes so much more sense. The moment you start adding interactivity back into the page, it's making more sense to have the same thing on the client and the server, and then it can just talk to each other, and then you're weaving patterns, and it's beautiful. But that's not really for today. Today we're just gonna talk about something more simple. So we do the get data. The get data basically loads this JSON file, does a little bit of mapping. We get that background, gradients, and in case of both, and we check which games are available. Then we just map. This is all standard React stuff, and then over here we grab our sprite via the background image, and then the trick of the day is to just create a Sprites sheet. It's nothing more than grabbing all these buggers next to each other. Let's see. So instead of requesting them one by one, we just made a new PNG that has all of them, and then really do an offset in the background position, and that's the video, really, pretty much. So if I clear this, load this again, I have a single image, and it's all a lot faster for good reasons. And, you know, in terms of data that you send over the wire, that's pretty much going to be the same. But the fact that, you know, 200 requests, no matter how many cores you have, you're just going to need to do some of that sequential. And now they just have it and it's all near instant. So how did we create this sprite sheet? That's maybe one other topic of interest. If we go back to the code, I have a little script here. So this one was like to set up the data. And this is something that's going to use Sharp. So if you ever need to do something image manipulation, whatever, you really want to use Sharp. The interesting part here is that I'm doing some bindings to the outside world. So within ReScript, similar to TypeScript, like type definitions, we're adding some of these our own, but we're only going to add what we really, really need. Like there's no Sharp install package JSON for ReScript specific bindings. That typically isn't going to exist. And the reason for that is that it's not that the ReScript community is too little that you're probably going to be the first one to use Sharp and ReScript together. That's not it. But what you need and what somebody else needs might not be worth it to spend, you know, an entire effort to get a single package out there with all the bindings. If we look at what we actually need from Sharp, we don't need that much. And that's why it's just interesting to model this as a type of T. So, you know, you need to look at the docs of Sharp, how that actually works. But in essence, you create like a Sharp default, and then there's some like helper functions with that T, which then returns a T, builder pattern kind of style. And that's all we need. So it's just sometimes a lot more interesting to have these little bindings and then get on with life. Same with some node stuff. So Sharp needs a node buffer at some point. Well, we can create this from an array buffer. That array buffer is going to come from somewhere else, from a fetch call probably. There's a node path resolve. There are bindings for a node, but instead of, you know, dragging another dependency and hoping that will, you know, continue to work over time, it's easy to just do something like this, add this one little resolve binding and then, you know, get on with it. So what do? We do a get all Pokemon. So that's actually the same call we do in our get data over here. Then in our sprite, we're just gonna grab the Pokemon, grab the sprite URL. Then you basically, you know, want to download the image. Downloading the image is using the fetch binding. So the reason, you know, there's no module fetch here, it's in a different file because I reused it elsewhere. But that's basically your node fetch function, or bun in my case. We don't need anything else from fetch them. Just like, okay, it gets a string and it gives me a response of T. And that response can either be an array buffer or JSON for something else that I'm using. And that's good enough. Like there's no need to add anything more than that. And you also have a good idea of what surface area is covered by your bindings. Like what am I actually using of Node, for example. And if I ever want to go to a new Node version, I can basically, you know, check back in my sprite. Oh, is buffer, is that still there? And is path resolve still there? And you're done. So, you know, you're a lot more aware of what you're using. Images, download image. Download image does the fetch call. Fetch, get an array buffer. And then you sort of pipe it through some Sharp stuff. We can basically create a Sharp instance, a Sharp of T of that buffer. We're gonna resize it. So we just have like a thumbnail size of 100 pixels. Create a PNG image as a buffer. Return that buffer and then give it an offset. So basically we're creating all these images with an offset, and then we're gonna merge them into one sprite sheet. So we have, this is gonna be like our end result. Create a brand new image with the width, which is the total width, and then the thumbnail size. And, you know, compose it of all these other images and save to disk. And that's it. That is pretty much it. Like you can see we're building up to something. There might be a next video where we do some client interaction and, you know, do some more server function maybe to see where this is going. But I just really liked my little sprite sheet idea. Like, remember the game development videos? That came from that. So it's like crisscross. Oh yeah! anyway, that was kind of it. So we made a sprite sheet in this video. Good stuff. Key takeaways: sharp is nice, and do things you like. That's really what this is. So yeah, until we meet again.